Hello everyone, my name is Austin and welcome back to my channel. Now that my CNC is all tuned up, we are finally going to start building the neck for this guitar. So today's plan is that we're going to go ahead and surface our wasteboard so that it's nice and parallel to our gantry like we talked about in the last video. And then we're going to go ahead and make this fixture, and then we're going to cut both sides of the neck. Now we're basically going to follow the exact process that I laid out in my cam for flat guitar necks video. So if you want any more information on this process or this fixture or any of the tool paths that I'm going to be using, you can find out all of that in that video. I'll leave a link down in the description below. So let's not waste any more time, and let me show you how I turned a blank of mahogany like this into a neck like this. Let's dig right in. All right, so I've set up my 3/4 inch surfacing bit, and I'm just going to go ahead and bring that over to roughly over top of the corner of my spoil board here, and I've got a program that will just automatically cut the size that I'm looking for. So let's bring this over. Let's bring it down. Okay, and I'm just trying to get it roughly centered. It doesn't matter because I'm just going to be going over the edges anyway. It doesn't matter that it's particularly accurate. I don't really need to zero things like crazy. Okay, that's roughly center there. And that's roughly center there. So let's go ahead and make that X0, Y0. Okay, and then I'm gonna jog it over a little bit, and we're gonna zero our wasteboard, or zero to our wasteboard right here. And I generally tend to just use like a little flashlight or my magnifying glass to shine behind it until I see that it touches, and as soon as I see it touches, I'm good. So let's go ahead and bring this down. Sometimes what I'll just do is I'll just feel it. If I can feel it kind of rubbing. Okay, it's not quite there yet. Let me go down a tad bit more. Grab the... Okay, that's perfect. I can just barely feel it scrubbing. Don't need to plug in any sort of probe or anything like that. We're just trying to get this roughly set up, so that's going to be Z0. And let's jog up. Okay, Z up, go back to X, Y, 0Y. Okay, now I normally have a hose system connected to a dust shoe, but unfortunately for this case it's not really going to show up on camera very well, so I'm just not going to use this in this case, but I might end up having to use this later when we're making significantly more chips. So I'm just going to set that down for now, and let's go ahead and turn on my spindle, set it at the lowest setting, make sure everything else is out of the way. Yep, there's nothing on my spoil board, so we're good. Okay, I'm just gonna hit play. And yep, got it. Okay. Just gonna retract up a little bit. Let's speed that up just a little bit. Okay, so I'm taking a 16th inch off right now. I'm gonna turn on my vacuum, and I'll see you guys back in a minute. Okay, so we've surfaced the wasteboard, and as you can see, you cannot tell or see really any tool marks or even any ridges or anything like that. And so let me go ahead and zoom in here, and let's look down. Yes, you can tell that we got a really good tram on our system, without doing any test cuts, because there is almost zero tool marks or ridges present. And on some areas you can see like a faint hint of a line, like right there and right there, but there's no, you can't feel them whatsoever. It's completely dead smooth. So that's because we took the time to do a really good trim on our system. And this is probably honestly the flattest this Wasteboard has ever been since I've owned it. So I'm really happy with that, and I think it's time to move on to the fixture. So I started by trimming up some 1/2-inch phenolic plywood to a width of about 7 inches. Now, I really like using this material for fixtures because tape sticks to it really well compared to MDF, and there's far less chance of my parts breaking free by accident mid-cycle. It's also very easy to clean and substantially more resilient for dowel pins because it doesn't teardrop the dowel pin holes as easily when applying clamp pressure. So for me, this is my ideal fixture material. Then I swapped out my 3/4 inch surfacing bit for a 1/4 inch 2-flute downcut carbide end mill, so that way we can start cutting the fixture. Now I typically use downcut end mills for most work on my CNC as they leave a nice top surface and apply downward force to my Wasteboard. Then I installed 3 dowel pins in my Wasteboard that I use to align and square my parts to my CNC. And then once it's aligned, I use 2 clamps to hold it in place to make sure my fixture doesn't go anywhere. Okay, so I'm just gonna eyeball this because I made this board about 1 inch wider than I actually need it to be. So I'm just gonna eyeball it to right here and then go in about 1/2 inch. So that way I can cut reasonably within the middle of this and have my fixture start at this board right here. And so that's what we're gonna do. Okay, and we're gonna do the same thing. We're going to shine a light behind there. And I'm gonna rotate my bit, bring it down a little bit more. Let me see if I can bring you guys in on this. Hold on. So unfortunately I can't get the camera quite close enough at this angle to go ahead and show you perfectly. But what I do is I shine a light behind it, and then I jog my Z-axis, or not my Z-axis, my X inward until I'm pretty close. And then I will keep going in a little bit further and I'll watch the shadow on the side of this as it creeps towards the bit as I bring the bit in. And as soon as it gets really close, almost touching, like right now, I'll switch it to 1 thou increments. And I will just go until I see that the bit is touching. So we're almost there. Okay, that's perfect. It's just starting to scrape the side. So that means we're dead on right there. So that's going to be my X0. And let's jog our Z or our X out a little bit for some clearance. Jog our Z up. And we're going to go to X0. So we'll do, I'm going to set my Y0 for the moment. And we're going to go X0, Y0. All right, and so I'm going to jog that in 0.125 because this is a 1/4 inch bit. So X 0.125, and that is going to be my new 0. So now I'm going to say X0, got it? Okay, and now I'm going to jog this in. Let's see, my fixture is 6 inches. I made this 7 inches, reasonably close, but not perfect. So 7 inches, so I'm going to go in 1/2 inch. So I'm going to say X 0.5. Okay, that is going to be, so my bit is actually going to end up being to the outside of that, and that's okay. But that's going to set where my corner is. And so now what I just need to do is, let's get it lined up a little bit with Y. So I'm going to bring the camera over here and let's zoom. There you go. Okay, and we're just going to eyeball this a little bit. Sorry for the camera work. I'm doing this kind of sideways. I'm going to go, just get it reasonably close. Doesn't have to be perfect. We're going to end up drilling dowel pinholes. In fact, I think I might just go a little bit further in. Yep. Maybe even a little bit further. Okay, that'll work for me. So that means that my my fixture is going to lie, the edge of my fixture is going to be right on the center mark of this bit, which will be just shy of this board. So it'll be just to this way of this board right here. And so that should be good. So I'm going to zero my X and Y. Let's bring the camera back. Okay. So we're going to do X0, Y0. Okay. And then all we need to do is find Z. So I'm just going to do the same thing I just did a second ago, where I shine a little light. I don't use a probe for this because I can get pretty damn accurate with just doing it this way. So I'm going to go Z negative. Okay, I need to smaller increments. Okay, shadow's almost there. Let's go in 1 thou increments. Okay, I'm not quite scraping it. Just a tad bit more, maybe 1 or 2 more thou. I'm gonna grab my, never mind. Okay, we're like a thou or 2 off here. Doesn't really matter for what we're doing right here, but I always try to get it perfect if I can. Okay, perfect. I just started to feel it scrape. Just barely. There's almost no line on it. So we are good there. So I'm going to say that is Z0. So I should have X0, Y0, Z0 right at that point right there. So now I'm going to jog my Z up for a safety height. Just get it off the wasteboard here. Okay, so that way I can turn on my spindle and everything. Now I normally have a dust shoe connected to this, but for purposes of filming, I'm going to go ahead and run it without it, even though my wife will probably get really irritated with the amount of dust that'll be in the shop, but we're going to go ahead and clean that up later. But that way you guys can see it a little bit better. So I've loaded up my program. Just double check everything. I've got my X0, Y0, Z0. And we are going to be cutting the slot that goes around my neck. And then we're going to be cutting roughing in the dowel pin holes for both alignment for the fixture and alignment for the part during the flip. And then we're also going to be cutting afterwards on a separate operation. We're going to be fine-tuning those holes. And then we're going to be cutting the contour last. So that way I can go ahead and insert dowel pins into the actual fixture to help hold it in place so it doesn't break free and I don't have to use tabs that way. So let's go ahead and we're going to start this. So it should be good. All right, program's running. Okay. I'm going to adjust my spindle speed as much as I need. Dowel pin hole. I think I was cutting into my aluminum there. That's not good. Yeah. Alright. Well, we're gonna run it. Yep, I'm cutting into my T-slots there, so that's a bad. Oops. Okay, so what I should have done was measure the distance between these two dowel pins. So that way my dowel pin didn't line up with a T-slot. In fact, I ended up just cutting right through my T-slot, and that kind of sucks. Those aren't cheap. So what I'll probably end up having to do is I'll probably leave this dowel pin where it's at and leave the fixture exactly where it's at. This one is, yep, we're good there. It's pretty nice into the center here. These ones are a little closer to the edge than I'd actually hoped for, but they should be okay. So yeah, what I think I'm gonna do is go back to my stock, add in some dowel pin holes a little bit further back on the stock, and we'll see if we can compensate for that. So I've gone ahead and I have updated the length of my fixture to be 1 inch longer, and so that way it moved those dowel pins in the back to 1 inch further back, and we're going to go ahead and recut just that portion. So I exported that as its own tool path. So let's go ahead and turn on the CNC. We've already sent it back to XY0, and let's run it. Okay. So it should cut those 1 inch further back. For pretty aggressive feeds and speeds. I probably should have done that a little slower. So when I do the cleanup ones, I'll go ahead and make those a bit slower as well. Okay, I'm happier with those. That's the end of that tool path. So I'm just going to go back to my machine, update the feeds and speeds for the cleanup operation so we can size these holes to just the right size. Okay, so I'm going to go ahead and send this back to XY0. And then we're going to go ahead and upload the new G-code. So what I'm going to do is I have a G-code set up so that it cuts this hole, and the new 2 back holes, and taking 5 thou extra off, and I'll do a test fit with my dowel pin. Now I've already done 1 test fit on here, and it's definitely too tight. I can't get it in there, so I'm going to take about 5 thou out, see if we can get any closer, and then once I feel like I'm almost there, I'll take in 1 thou increments, and then we'll get it dead on. So let's go ahead and turn on our spindle. And then I'm going to hit play, and let's run it. So I'm actually just going to pause the program now and test the fit so I don't have to spend the time traveling all the way to the other side. So it looks like we are still too tight. So I'm going to go ahead and take about, I'd say we're still probably another 5 thou out. So I'm just going to go nominal, just 0.375, and let's see how close we get. Turning on the spindle, doing it again. Okay, shut off the spindle. We should be really close here. Yeah, those are pretty snug, but they will go in. I think I want these to be a little bit looser, so I'm going to take 1 extra thou out, and I think we'll be okay. Okay, that's about what I'm aiming for. So they're still pretty snug, but I can get them in and out as I need to. So I'm happy with that. So I'm just going to turn my spindle back on, and we're going to keep resuming the program and let it cut the rest of the holes. So we'll go ahead and go play. I'm going to cut this hole as well. Okay, and because Fusion doesn't like people using G0 Rapids, LOL, my machine's moving at a snail's pace, unfortunately. So that's okay. I'll see you guys when we get back. So moving along, we're gonna go ahead and stop that program, move it back to X0, Y0, and we're gonna go ahead and resize the dowel pin holes for the actual neck itself. So let's go ahead and upload the second dowel pin sizing file. And let's turn on our spindle and hit go. Okay, so we're gonna resize these ones to the same size. Let's check our hole sizes again. So we'll come down here. Yes, those are nice and snug. There's still some dust in there though, which is kind of clogging it up. Oop. Okay, let's see if those fit just maybe a little bit better. Yeah, those will go in with a little bit of massaging, but I want these ones to be tight anyway once we get that finally cut. So we're good there. This has been somewhat of a nightmare, but I'm also super excited with the results. I made a lot of mistakes this time around, particularly in machining my fixture and these dowel pin holes. I'll get you guys a close-up on this in a second. What ended up happening is I originally had one dowel pin hole here in the middle, and now you can see I've got 1, 2, 3, 4, 5, 6, because I either forgot to zero my work offsets when I did the dowel pin holes, or the part moved, or they were too tight, or sorry, they got too loose, and then I ended up having to do new ones again, and it was just a nightmare. And so I apologize that I didn't maybe show some of that in its full extent, but what we ended up with was a really nice neck, and I'm really happy with it. So we've got the truss rod, the full contour, We've got the relief for the tuners, and we've got the 3D little toolpath I made that in the neck cam video turned out really well. I'm really happy with that. You can't see any tool marks or anything, so that's great. One downside is I normally like to be a little bit more precise with the hole sizes of things like I did with my dowel pins. I don't have the tuners here yet, and so I just did these two nominally 10 millimeter, although I know my CNC makes them a little small. So I don't know exactly how accurate those hip shot tuners are. And if they're exactly 10 millimeter, then I'm gonna have to probably sand those out to open up the hole a little bit, or maybe buy like a 10 millimeter reamer and come through and clean that up. So we are now actually set up for the flip. So let's go ahead and flip this part over and do the backside. Okay, I think we can wiggle it free. There we go. All right. See, I damaged my fixture a bit, but that's okay. Not a big deal. It's not damaging the part. Now, I normally don't have that issue because I normally don't install the dowel pins beforehand. So that was a big lack of foresight on my part. Okay, let's make sure we orient it the correct direction. Yep. Okay, so that should be good. Let's get these lined up. Grab a block here.
Two hours later.
Okay, that should be good. Let's go ahead and reclamp this up. That'll help hold the glue down. It's not really that necessary for everything else though. This is just to keep the fixture from moving. So go ahead and clamp that down. Okay. I did that backwards. There we go. Okay, everything looks good. Part is oriented correctly. Put the hammer away. Okay, so I'm gonna check my work offsets because I ended up having to take this off in order to get the part off. So I need to make sure that my work offsets are still accurate. So let me go ahead and do that and we'll be right back. right, well, there you have it. We have a semi-finished guitar neck that turned out beautiful. I am super thrilled with the way this turned out. All of my transitions came out exactly like I had hoped in the model. There are a couple things I would change though. So one thing I would change is my step over on the neck. And I've talked about this with some of the people in Discord. I used a 1/4 inch ball nose end mill with a 32nd of an inch step over. And it actually turned out, as you can see, really nice on the neck. But in the headstock transition and some of my heel transitions, the tool marks are pretty extensive, and that is going to require a lot of sanding on my part. I think in hindsight, what I would have done better, or how I would have been better served, is by using maybe a 10 thou step over and hopefully even a larger ball nose end mill. So that way I could leave myself very little sanding or scraping work to do at the very end. But that's okay, you live and learn. Either way, this neck looks beautiful. This truss rod just fits like a glove. It just clicks right in, so I'm really thrilled with how that fits. And don't miss next week when we're going to be taking this beautiful piece of wenge material and be making a fretboard out of it and eventually gluing it onto our neck. So I will see you guys in the next video. This is Austin, signing out.